Hello everyone, my name is Andrei and I wanted to make a tutorial in which we're going to make an advanced crack generator for Substance Designer. And in this tutorial, I'm planning to use the fxmap node to generate the cracks. And maybe more important is this idea that you can take something that might be complex and think about how you might break it down into more simple steps and manageable parts. And I think that could be interesting and useful for you. So, what I'm trying to say is that I'm not thinking of making a perfect generator right away, but more like figuring what the steps are and how to approach it. So we're having this graph and we're going to rebuild everything from scratch. But maybe we can try and think a little bit about a way in which we can describe this process. So, to me personally, it makes sense that a surface cracking might start with simple cracks like so, and then as the time is passing it develops more cracks and then more cracks and even more cracks. And what I want you to notice is the fact that we have an initial state and then we have like 3 stages that looks identical. And this is quite interesting to notice, because in order to make this system work, we just need to figure out the initial state, how to make it, and then we only need to figure out this part, and then we can duplicate this as many times as we want, and our cracks pattern is getting more and more complex. So from simple to more complex to even more complex to even more complex. And before we're going to dive into more details, I want to show you some of the things that you can do. So first of all, you have a parameter here which I conveniently named crack length. So if I'm going to lower this value, you can see that our secondary cracks are shrinking and we're just left with the first set of initial cracks. So from the set of initial cracks, it makes sense that you would grow a secondary set of cracks, and then from the secondary set of cracks you would grow another layer of cracks, and so on and so forth. So this is the process that we're going to replicate. All right. So I also wanted to say that this first part here, the initial cracks, can be generated with more traditional nodes. Like for example, you can use a tile generator or a tile sampler, or if you want, you can actually input anything here as long as it is like a black and white mask. So for example, I'm going to use a text node and maybe choose a letter for us. A maybe should be fine. I'm going to rescale it a little bit and just use it as an input here. And after the first step, as you can see, we're developing this type of pattern. And then in the second stage, we're getting this. And in the third stage, we're getting this. So you can practically use anything that you want. And you would have some parameters that will allow you to adjust the look of it and make it a bit more, depending on the situation that you have, those parameters would help you or will help you achieve the look that you want. Okay, so let's try and get it started. I think I will use a more generic shape as the beginning. So let me create a frame node and rename it initial state. So we're going to start with this. And it can be a situation like this where you have like many cracks, small cracks, but we can also use a shape. I'm going to use a disk, shrink it, scale a little bit, and I also want to just deform it, not too much, but just to break the perfect circle a little bit. So I'm going to warp it with a early noise node. Maybe a Gaussian noise. And I want to lower the intensity of the warp a little bit. Something like this maybe. Okay, so I'm going to use the FX map to create some lines that are climbing on a vector field. And I'm going to explain this in a bit. So first of all, we are going to use a distance node. And this distance node, as you can see, creates like a gradient from our shape in all directions. And you can think of this like a mountain, and everything that's dark is low and everything that's white is high. So we're having a slope that we can climb from dark to white. And with the FX map node, we're going to actually draw some lines that are climbing this kind of gradient from low values, from dark values to bright values. And we're going to also use the normal map node that is going to generate for us the normal vectors. And in this case, we can think of vectors as being directions that will guide our lines and kind of show the lines the direction in which they should grow. Okay, so good. After the distance node, we're going to place a normal node. And I think we are good to go and start our fx map node. And the fx map node can be, in this case, a grayscale node, and I'm going to plug in the normals here. Okay, so we're going to dive inside the fx map node, and with the fx map node selected, I'm going to press Ctrl+E, and I think if you are watching on a Mac computer, then I think you would need to press Command+E. So now, as we are inside the fx map node, we're going to change some things. First of all, I'm going to change the blending mode from addition and subtraction to maximum, and the pattern, we're going to make this a maybe a paraboloid, and I think for now we're just going to make it arbitrarily small, like maybe something 0.01 and 0.01. And at this point I need to explain something that is kind of important with this particular setup that we're making right now, and meaning we are using the fx map node to draw some lines that are climbing a vector field, and the coordinates of our image space are from 0 to 1 in x direction. So this is x direction, and this is 0, and this is 1, and in y direction we have 0 here and 1 here. And in order to make everything work properly for us, we need to offset this point here into 0, 0, 0, 0 in image space. So the fx map node considers 0, 0 to be here in the center, but in order for us to align with the image space that we're going to input in, we need to offset this here. And luckily for us, the fx map node has a separate way of doing this kind of stuff. So you can see we have branch offset and pattern offset. So you can use either one of them to do this preliminary offset, such that we will move the 0, 0 from here to 0, 0 here. And I'm going to use the branch offset, so I'm going to just say here minus 0.5 and minus 0.5. And right now our 0, 0 right now in the fx map node is here, and this is good for us. So what we're going to try and do, we're going to create this kinds of line by adding together many circles, and those circles are going to be very close together, And for these reasons, we will perceive those points being very close together as continuous lines. And we're going to do that just now. So I'm going to use a iterate node and always plug the quadrant node into the right slot of the iterate node, and then select the iterate node, right click and set it as a root. So right now nothing happened yet, but we're going to very soon change this kind of stuff. And we're going to again select the iterate node and go inside the channel here, like the iterations channel. We're just going to hit this and create a function inside this channel. And for right now, I'm just going to create a float2, which is again 0 and 0. So this is like a vector that has this position. And for example, I can change this to 0.1 and 0.1. And in this case, 0.1 is in X direction around here, and 0.1 is in Y direction around here. So our point is right now somewhere around here, or this vector is somewhere around here right now. And we need to set this variable and give it a name. So I'm going to use the set node and name it origin. And by the way, you can name this however you want, but it's just good practice to use a meaningful name and try to remember the exact name, or copy and paste it in order to make sure the substance designer is not getting confused because you somehow misspelled or make a mistake somewhere, and this might cause you issues and you're not going to know exactly what's happening. So just be careful with the naming and make sure you're using the correct naming everywhere. Okay, so we created a variable right now which is named origin, and we then need to use a sequence node, and then we will also want to output how many times the iterate node should run. And I really want to draw your attention, whenever you're inside a node or inside the function, look here in this corner of the graph, and it should say like the expected output type is. So depending on the channel or depending on the node, you're going to have something different here. So in this case, it's an integer because you're mentioning or you're specifying how many times the iterate node should iterate, and this is like an integer value, and an integer value is just like a whole number, like 0, 1, 2, 3, 4, 5, 6, 7. This is an integer number. And by contrast, a float is something that has a decimal point. Like for example, 1.53, this is a float, or 1.00, this is a float. And in this case, the last thing that we need to plug into the sequence node is basically the output that this channel is expecting. So we're going to use an integer and say how many times do we want the iterate node to basically repeat the instructions. and we're going to say like 50 times, and we can change this number later. So for example, this value here is going to be our cracks length, the parameter that you saw earlier in the demonstration. I'm going to plug this in here and set this one as an output. Okay, so still nothing has changed, but in fact the fx map node has iterated 50 times through all the fx map, and right now we're having like 50 paraboloids sitting on top of each other in this space. So definitely we can't see them because they're sitting on top of each other, but there are definitely like 50 paraboloids sitting on top of each other here. Okay, so now that we've done this part here, we would like to actually make these paraboloids climb the vector field and follow the directions, and in the process of following those vectors from the normal map, they are going to trace lines in this 2D space. Okay, so we're going to go back right now into the quadrant node, and I'm going to use the pattern offset channel to move these points around and create a line. What I would usually do, because it's more convenient, is I would go and put all the instructions here in the luminosity channel, and then just set up variables and call those variables into the other relevant channels. Like for example, you can specify the position of the patterns, the size of the patterns, and the rotation of the patterns, and here the brightness and the luminosity. So whenever you're going to actually use all the channels, it's a bit more convenient to have all the logic in this channel. But in this case, in order to make things a little bit more simple, I'm going to use each channel for its designated purpose. So in this channel, we're going to put the instructions that are going to define the positions of our patterns. Okay, so I'm going to go inside, and inside this empty function, we're going to take the variable that we created, and we created a variable called origin, and then we're going to redefine it. Okay, so we're going to get a float too, and at this point it's good to double check, go here and click this one and copy this text just to make sure you're not making a mistake. So we're going to get the origin, and this origin, if you remember, it's somewhere in space around here at coordinates 0.1 and 0.1, and we want to sample the normal map at this position and read the vector that it's sitting at this position in the normal map. And this vector here is going to tell us where to go next. So if you imagine, we have a point here, and then at this point we're having an arrow that it's pointing in this direction, so toward the center. And we're going to say like, from this position, move into the direction of this arrow a little bit, and then we're going to redefine the obtained position as the new origin. And then in the next iteration, we're going to say like, from this position that is right now the origin, add the vector from the normal map, so look at the direction and go into that direction a little bit. So now this is our current position, and let's say that our direction right now it's from here in this direction. So we're going to move a little bit here and again set this as the current origin. And we're going to do this kind of stepping into the vector field a little bit. And let's do that. So we're going to sample our normal map, which it's image input 0. So okay, and we need only from this sample corridor, we only need to work with the x and y coordinates of this vector. So this is a vector float 4. Whenever you're seeing this blue output here or blue circle here, it means that this is a vector float 4, and we only need the x and y component, which is a vector 2. And in order to extract this, we need to use the swizzle node. And you can see we have swizzle float 1, swizzle float 2, 3, and 4. We're going to use swizzle float 2, and we can put this in here. And right now we just extracted the x and y coordinates. And another interesting and important fact is that normal maps usually have, I mean not usually, but all the time they have negative values. So vectors are pointing in all directions. Like if you imagine a circle, vectors are pointing around, all around the circles, and some of those vectors have actually negative values. But in order to avoid having a negative values and 32-bit images, because in order to access values outside of the range 0 to 1, you need to save or to store your image into 32 bits depth. So after computing the normal map, they usually usually the range from, it's probably the range is somewhere from -1 to 1, and I think it's converted, I mean definitely it's converted from negative to positive into 0 to 1. So in order to fix this previous conversion from -1 to 1 into 0 to 1, we need to actually do the reverse operation. So we just need to multiply the vectors by 2. So we're going to use a scalar multiplication. So this is a vector, and in order to multiply it by a number, you need to use a scalar multiplication. So we take the vector and we multiply it by 2. So right now, if this is like from 0 to 1, after this multiplication is from 0 to 2, and then we need to subtract. We need to subtract this time a vector 2, so a float 2 here, and 1 and 1. So remember, this is, if this is from 0 to 2, by subtracting 1 from it, it's going to be from -1 to 1. Okay, so right now we actually reversed the effect of changing the range of vectors that happened here in the normals node here. So right now we fixed that, and I think it might not be absolutely necessary to do it right now, and in this case, but I'm going to anyway do it. So after this, we're going to normalize the vector. So right now every vector will have the length of 1, and then we're going to multiply those vectors by a small number. And at this point, I also want to introduce you with how can we specify the distance between patterns to be in pixels. So we're going to multiply this normalized vector by something, and that something is going to be a number. So for this reason, we're going to again use a scalar multiplication, and we need to figure out what should we put in here in order to be able to specify in pixels the distance between these patterns. So in order to get the size of a pixel, we need to get another variable, and if you choose get float 2 and then go under this drop down menu, you will have size and position and size log 2, and we're going to choose size. So this is the size of our image space, and this is equal to the resolution of the node. So the size variable will output right now 2048 by 2048. And in order to actually get the size of one single pixel, we need to take 1, which is the entire image. So 1 is the whole. Our image is the size 1, and we want to divide it by the size. So 1 divided by 2048 is definitely a very small number, and it's of course 1 pixel. We're going to swizzle it because we just want a float number as a result and not a vector, and then multiply this by how many pixels we want the distance between our patterns to be. So for example, let's say that we want 10 pixels to as a distance between patterns. And I'm going to put a comment here and say is the distance this is the distance between patterns expressed. Okay, and we can plug this in here. So right now what we are doing is we are looking at the current position of our pattern and then sample from the normal map the direction, and then the next step that we need to do is actually update our origin for the next iteration. So in doing so, we need to take our origin and add it to our direction. So everything in here I'm going to put into a frame and say direction. And at this point I really want to make sure you hear this information. Position and direction are vectors. So this is like very important stuff to remember, because we will encounter this idea many times. So we are going to update a position by using direction. So we're going to use this many times. Okay, so at this point we have our origin and our direction added together, and this is our new origin. So in order to redefine it, we're going to set again and say origin. And again, this is very important to remember. This kind of structure you will encounter like many times. So getting a variable, updating it, doing some operation, you're updating it, and then you set it again. So origin is the position, and then we add a direction to it in order to get the new origin. Okay, so I think at this point we can just right click and set this as an output, and if everything is correct, we should see something. So you can see right now that we're having a line which is made out of these dots. And in order to uh, figure out what's going on, we can go here and into the iterate node and just play with this parameter. So right now this is doing like 50 iterations, but if we are going to 1, you can see like this is our origin, so this is the starting point, and let's put it here like 0. Maybe 0.35 and 0.35, something like this. And at this point I want to show you what's going on. I'm going to use a levels node to darken the distance field a little bit, like so, and I'm going to plug this in here. So as you can see, we're having a point here, and this point it's actually traveling along this gradient from this value, which is bright, to a darker value. And if I start and increase this number, you can see how it's traveling. So putting 50 here. And in order to reverse this direction, we can just go in here where we put the instructions for our offset, and maybe the easiest way to do it is just multiply this distance. So this is the 10 pixels distance between patterns. You can multiply this by -1, or just use this negation node. So as you can see, it changed direction. And just wanted to say, let's test this. So maybe put like 32 pixels, so you can see that this is actually controlling the distance between our patterns. Okay, so maybe let it like 5 pixels between this, maybe, I don't know, maybe 3 pixels. 3 pixels seems to be okay. Good, but this is just one crack that is traveling along a vector field, and we want many cracks. So how would we do that? And luckily we're exactly at the right place and at the right time, and we're going to make like a nested loop inside this fx map node. And for this reason we're going to use another iterate node. I'm going to hit undo because I was not expecting this to happen, so I'm just going to bring a new iterate node here and plug everything here. Okay, so what we want to do right now is just create a grid of points that is going to cover this space. And in order to make this very visible and easy for you to understand, I'm going to go here inside this channel and just make one iteration. So we have a single point in space, and this is the origin. And what we need to do is replace this value here with something else in order to have, we right now just have one single position that it's here at 035 and 035, but we need to generate a list of positions, and luckily we can do this. We're going to create a grid of maybe a grid of 4 by 4 points for starters. So 4 by 4 or 4 multiplied by 4, or a grid of 4 by 4 points has 16 points. Okay, so this new iterative node is going to have 16 repetitions, and we're going to set this as a root. And now we need to go back here and replace this part, and we're going to get the number. So this $number variable, it's actually the 16 times that we just set above, and this is creating a list of numbers from 0 to 15. 0, 1, 2, 3, 4, 15. And what we want to do with this list of numbers is create a set of positions or vectors that will take for each iteration a dot and place it like here and here and here and here. So I'm going to use some functions and I will explain them, but I think if you're aware of the basics of pixel processor node book, there are some slides, and in those slides I used many of those functions, and I think you would understand a bit more and better from those slides and examples how these functions are working and what they do. But I'm going to try and explain them anyway here. So we're taking this list of numbers and we want to make some list of positions from it, and we're going to use a mod function, and we're going to use a mod this value of 4 because we want a grid of 4 by 4. And what is the result of the mod function right now? So I'm just going to duplicate this. The mod function is taking this list, which is increasing by 1 from 0 to 15, and it's making it such that it repeats after every 4 consecutive numbers. So you can see it's 0, 1, 2, 3, and then it's again repeating, like starts from 0 and then comma 1, and let me make it a bit more nice, and then 2, and then 3, and then again it repeats. So from 0, and I think I will complete this list entirely, and then 2, and then 3, and then I think this is the last pair. So 1, 2, 3, 4, 1, 2, 3, 4, okay, and then 0, 1, 2, 3. Okay, so this is the result after the mod function. And in order to make everything from 0 to 1, because remember our space is from 0 to 1, we need to divide those values by 4. So right now the result of everything here is between 0 and 1, and we're going to make a vector out of it. So right now this vector has those values here, and if I plug right now here into the origin, you're going to see we're getting, in x direction, we're getting what we want. Right now we need to do something that will help us with the y coordinates. And what we're going to do is take our $number, our list of values, and divide it by 4. and then we need to make integers out of this. So the result of this has some integer numbers, like 4 divided by 4 is definitely 1, but 3 divided by 4 it's something that it's a floating value. It's maybe something like, oh, I don't know, 0 point something. I'm not entirely sure what the result of this is, but we want to make it like an integer. So we're going to take a floor out of this. And right now this is like, the result of this is going to be like 0, 0, 0 and 0, and then it's going to be 1, 1, 1 and 1 again, and then 2, 2, 2, and another 2, and lastly 3. Okay, so the last thing that we still need to do here is make this list of number range from 0 to 1, and we're going to divide this by 4. So right now we're going to have kind of the same list, but instead of ranging from 0 to 3, it's going to range from 0 to 1. And then if we plug this here, now we're getting our grid of points. And that is really cool. And just temporarily, I'm going to disable the tiling for this node, because I want to show you a small correction that we're going to make, and after that we're going to reactivate the tiling. So no tiling, and you can see that our grid starts from 0 and then ends up here, and we want to actually center it. So in order to do that, we can go here and make some additional operations. So we need to add something in order to move it here. So I'm just going to add a node, nothing changed, then use a float 2 and just test it for a little bit. So you can see what we want is to get it something like this. And those values are looking like something like 0.12 and 0.13 seem to be like very close to the right values. And how to make a mathematical operation that will give us the right answer depending on those values here that we're using. So in order to do that, we actually need to take the space that we have. So the length of the space that we have, this is 1, and then we need to divide it by the size of our grid. So 1 divided by 4, it's 0.25, and you might recognize that 0.12, it's almost like the half of 0.25, so we need to just divide this by 2. Okay, and then this is like 0.125, and we need to make a vector out of this and then just replace this test dummy value with this one. So right now we have this grid of values that it's centered, which is really good. And we are done? Not yet. We can do another interesting thing. We want to just randomize those positions a little bit. So in order to do that, we again will add something. let's test again and see what happens. So as you can see, if we add like a float 2, you can see that we're moving the entire grid up and down, and we don't want that. We actually want to move every individual point in a different direction a little bit. And how to do that? So luckily for us, there is a way in which we can create a vector um, by specifying not an x and the y coordinate. So this point here has an x and the y coordinate, and if we put them here, we obtain this position. But we can also create a vector or a position in space by specifying a length and an angle. So for example, there is a vector that starts here and has a length like this and an angle like this. So then the final position would be somewhere like around here. And in order to create such a vector, we will use the Cartesian node. And as you can see, it's taking as an input a length and an angle. And the length, it's like something like a percentage from the image space. So if you put 1 here, then it's like the entire length. So for example, if the initial position of the vector is here and the length is 1, then the final position would be here. And if the length is 0.5, then the final position is here. And if the length is 0.1, then the final position is somewhere around here. Okay, so we're going to put for the length right now a float, which is like 0. And then for an angle, we're just going to put a random value. And this angle here is expressed in radians. And radians are like 0, it's 0 degrees, and 2 pi, it's 360 degrees. And then, for example, if you just put pi, it's 180 degrees. So we're going to make a 2 pi node, which we have, and then plug this to a random node. And what's going to happen is that this random node is going to generate a random number from 0 to 2 pi. And because we are iterating 16 times, this is going to give us like 16 different values. Okay, so I'm plugging this here, and then I'm plugging this back here, and nothing happens. So we have like 16 different angles that range from 0 to 360 degrees, but then the magnitude or the length of our vector that we want to use to randomize the position, it's 0, so nothing happens. But if we increase this value, then watch what happens. Okay, so I'm going to just make this like 0.3 and something like this. Okay, so at this point we successfully generated a grid of points, and now we want everything to climb on this gradient. So if we go back here now and just increase this value, you can see that everything is climbing, which is kind of really cool. Okay, so now we have this setup here. I just want to delete this part, and I think we're ready to start and chain these kind of things together and get our crack patterns. So this is our initial state, and what I really like to do is place like anchor points here and denote this as an input. I'm going to also plug this here, and I'm going to make this as an output. Okay, and let me frame this a little bit so we can see this is one iteration. Okay, and maybe we can duplicate this and take this and plug it here and see what's happening. So apparently we're getting the same result. And I think what we need to do is we need to just change the seed, the random seed of the fxmap node. And it seems like we're getting somewhere. And this is right now not the greatest result, and I need to do an extra step. And for this reason, let me go back a little and show you what I mean. I'm going to put again a levels node and make the gradient a little bit darker and observe what's happening with our points. So I'm in this node here and I want to observe where are the origins of my nodes and how are they climbing. So they are climbing from their positions to the brighter values, and that is really good. But I also want to make another node, another fxmap node that is starting from the origins and goes into the opposite direction. And that's very simple to do. We just need to take this fxmap that we have, duplicate it, and just change the sign of the distance between the patterns. So go inside the fxmap, go here into pattern offset, and we just need to remove this negation here. So right now we have this into the different direction, and we can plug this here, remove this one, and you can see right now we have the full cracks in both directions. So this is one direction and this is the other direction. And at this point, I think what I want to try and do I want to do this or not? Maybe no. I think I will leave this here, and I think for simplicity I'm just going, in order to not create like a very very large and difficult to manage graph, I'm going to put this part here into a node. So in order to do that, I'm going to select everything, right click and say create graph from selection. I'm going to name it iteration. And drag this thing here, go inside. We need an input grayscale, and we need an output. And this is generating something like this for us, but if we plug this inside, we're getting the same result as here. Okay, so we can delete this part because we don't need it anymore, and now we have this part. And maybe we can create some parameters that we want to expose and have access to them in order to control our settings. So I'm going to go inside this one, And let me think what are the parameters that we want to create. So first of all, we're going to have something like thickness in pixels. So in order to create like an input or like a slider or a control, you double click on the graph, and then if I remember correctly, sorry about that. If I remember correctly, we just need to hit this plus button, and we're going to have like size in pixels. I mean pattern size. And because this is going to be in pixels, I'm going to choose integer, and I would say like the default value would be maybe 5, and then maximum like 256. Definitely not going to use that much. So we're going inside this node here, and here whenever we set pattern size, I'm going to go inside this channel, empty function. Now everything is super wide because we have plenty of circles or paraboloids on top of each other. We're going to get our integer, get integer pattern size, and then we need to multiply this by our equation that computes for us the size of the pixel, which is get float2 size and float2, which is float2, and we have a division 1 divided by the size. It's giving us the size of the pixel, and then we need to scalar multiply this. So we can't plug this directly because there is this is not compatible. This is an integer, this is a float. We just need to make this conversion, so from integer to float, and we can plug this here, and now our patterns have the size of 5 pixels. And if we click here on the node, you can see we're having this parameter that we can control, and maybe we can put like 10 pixels and maybe 20 pixels if you want, and stuff like this. So maybe 10 pixels is okay, I mean 15 pixels. And we want another thing to control. So for example, we need to do the same thing here. I will copy what we've done here. So under pattern size, we take this expression, copy it, and go into this fx map node, and go here into pattern size empty function, and then plug this here and set this as an output. Okay, so everything seems to be good. Okay, now we need another control parameter that will allow us to control how many dots do we want for our paths. So the number of dots is basically related to the length of the line. We also have the distance between patterns, which can also affect, but I think we should not interfere too much with the length between patterns. And I'm going to create another parameter like so, and we're going to name it like length, and this is going to be again an integer, and I would say like a default value of 50, and maybe maybe 300 as a maximum, and go inside this pixel processor. So here we have the length in this node. We're going to get an integer, and if we search here, we're going to find length and plug this in and copy this one and go here, and replace this one with the parameter. Okay, and delete this one. So now we have this parameter which we can control. Okay, and what else do we want? I'm not sure. Maybe I'm going to put a blur node here after the normal app. I'm going to put a blur node, and we're going to expose the intensity. Okay, so right now we're also having the intensity, and I want to move it to 0. And let me try and chain a couple of nodes and see what we're getting. And I also think I wonder if by changing the random seed here, yeah, it's good. So we can change something like this. So we're starting to get our crack or our cracking patterns, which is really interesting. But I think we might also want to add a few extra parameters that will allow us to get something a bit more robust. So maybe increase this length a little bit would make it interesting. Then on the second node, increase the length a little bit. Okay, so what I would definitely want to do is to be able to control the grid size. So right now we're having a grid of 4x4, and we would definitely want to play with this a bit more. So I'm going inside, and by the way, right now, because this node here is an instance, everything that I'm doing in either or in any of these nodes here is going to automatically update every other. So for example, all those nodes are copies of themselves. If I go inside and for example put a transform node here at the end and make it like so and plug this as an output, then every other node would have this same happening. So for example, you can see like this, and this, it's happening, and if you go inside you can see the transfer node here. But I don't want this to happen, just wanted to show you that the advantages of working with instance nodes is right now once you have a thing set up, then it's like super easy to update it, which is very, very good and super advantageous. Okay, so I'm going to delete this transform node and go back into the first iteration and add a new parameter. And again, this is going to be an integer, and we're going to name it like grid size. Okay, and it's going to be an integer, and let's say maybe the minimum should be 4, maybe 2, and the maximum should be like 100. Okay, so we need to update our two fx map nodes a little bit, and the grid, it's so right now the grid size is kind of 4 because we're having 4 dots for width and 4 dots for height. We can change this a little bit. We're going into this node here. We're going to make a simple function. We're going to get the integer, which is grid size. So grid size right now is, let me see, grid size, it's 2, and we need to multiply it together. So right now it's going to be 2 multiplied by 2. Okay, so we're only having 4 points and they actually don't show up correctly, so we need to update some things again. And where we calculated our grid, we need to replace this value here. So
Five doors, 3 previous owners, and a reverse.
So I'm thinking a little bit, what value should I put here? Or maybe if the grid size it's, oh yeah, of course, grid size. So I need to get in grid size again, and we just need to convert this to a float in order to become compatible with this one. I'm going to hold shift and drag this thing here. So right now you can see everything seems to be correct. Okay, and we need to do the same into this other pixel processor. So go here, into function, get the integer, grid size, multiply it by itself. Okay, so just delete this thing in order we again see just 4 dots and we are working with this one. Go here and correct our value here. So again, just get the integer, grid size. We're converting it to a float and replace this. So right now we're getting the correct stuff. Okay, and plug this back in. Just want to show you right now if we are changing the grid size, we're getting like the correct grid. Okay, so we're having this and we can increase the length. So we can again increase the grid size here, so we're having more cracks, and here again grid size, more cracks, and grid size, more cracks. Okay, and let me decrease the length here a little bit. Okay, if we invert this, it's looking interesting, but I also want to add an additional level of control. So you can see that it's looking okay, but I would like, if possible, to have a way to control like the density of these cracks. And right now we're having kind of the same, and I personally would feel like it would be more natural if we have like more cracks here close to the impact, and then as we go far away we would have less. So I'm not entirely sure how to do that, but anyway we can try something. So I'm just going to delete everything after this because we already have this setup in place. It's working very well for us. We just need to duplicate things if we want more complex results. But I'm going to go inside and try and make some things, and I want to use some information that we already computed, and I want to use my distance map for that. So I will take the distance map and plug it into this fx map here, and also plug it here. And first of all we're going here and try to make something of this. Okay, so we have computed here our origin, and I also want to say something. So at this point we have our origin, and I want to sample the distance node at those positions, and I'm going to sample. The distance is grayscale. I'm going to plug this, and the distance is plugged into the image input one, and we're going to say if we're going to say that if the distance field at these positions is greater than a high value, then keep those points, otherwise remove those points. So we should get points closer to the center, and then we should not get points far away. Okay, so greater if the points, or if the distance field at this position is greater than a value, and in this case I'm going to say like 0.98, then we want to make this white. So every point that samples the distance field at a value of the distance field greater than 0.98 is going to make that point white, otherwise it's going to make it black. Something like this and something like this. And then we will store this result into another variable called lum from luminosity. Okay, setting a new variable called lum, lum, and then we need to put another sequence node. So plug the origin here, plug the lum here, and plug this here. So something like this. So nothing changed yet, but we will see immediately some things. Okay, so right now we are on this quadrant node. We're going into the luminosity, and we're going to get float lum. So this variable that we just created, and now set this as an output. Okay, so everything disappeared, and this is probably has to do with the value that we created. So let me go back here and maybe decrease this a little bit. Okay. So now we have another way to control basically how many cracks do we have. And I kind of really like this one. We need to do the same with this. So I'm going to copy this logic here. And by the way, we need to create a new parameter here in our iteration node, create a new parameter and name it fresh. Maybe this H is not okay here. I'm not entirely sure how to spell correctly threshold. My English is not very good. I really apologize about this. I'm not sure. Okay. So we're having this. The default values I'm going to say like 0.9 and go back here and say get float fresh, and we're going to plug this one here. And now I'm going to copy this logic and paste it into the other fxmap node, I mean here. So adding this part here. Okay, so I think we only need to do this and set this as an output, this, okay, and this. Something seems not to be okay. So this everything is working, but here it's not working. Why? Yeah, we still need to go here and put the luminosity variable. Okay, so we brought LUM here and that is as an output. Okay, so right now we have another way to basically control how many cracks do we have. So I like having the first set of cracks very close to the impact. Okay, and play with the length a little bit, and then have the second node. And now we're having this kind of cracks, and maybe if you want like more or less, and then stuff like this. And do we have like pattern size? Yeah, we have. So for example, right now we can go and say like, hey, maybe we want the secondary cracks to be a bit thinner, something like this, and then duplicate this a little bit and stuff like that. So as you can see right now, we're starting to get kind of interesting results. And remember to change the random seed also. Yeah, I think it's interesting. And remember that in the beginning I said that I think it's more important to create a system or a node that gives you it it makes in a way your life easy, because it offers you some automation and some parameters that you can control, and it gives you like fair or good results. But it's not like one node that just gives you like right away good results. So you can see we break down this process into some steps, and at every step we have the possibility to manage and to tackle the result a little bit. And I think this approach, it's kind of, it's not fully procedural, it's semi procedural. So you have something procedural, but you also have your manual input. And I think a good balance of these two might be the best approach to get something fast but also have like creative control, because otherwise it can become a bit tedious or very difficult to make something like fully automatic but also have the control or the degree of freedom that you wish, or the level of control that you wish. So I believe making it and breaking stuff into smaller bits is probably the sweet point that you want to find with your generators. So yeah, I think that might be an interesting idea, and if you manage to stay this long, congratulations. I really apologize for the many mistakes I probably made during this recording. This is the first session ever that I'm making, and it's a bit difficult to find yourself talking. It's kind of strange, but I feel I will be able to make progress, and probably with time everything is going to improve. And I really wish you would have something useful and interesting to gain from this material. So yeah, maybe let's, I don't know, let's replace this input with something else. Maybe just make a text node and say cracks. And maybe just input here. So this is the first iteration, and then the second, third, fourth, and so on. I don't know, I feel like it's looking interesting. Yeah, I really like it. I'm going to delete the first part because I don't want it to be distracting, and I also feel the way in which we covered things in the tutorial, it's a bit more organized, and I'm more satisfied with the results. Yeah. Well, thank you everyone. I hope you had a good time, and I hope you're not bored to death by listening to me and my voice. So yeah, I'm planning to do more tutorials like this, and I have quite a lot of new and interesting ideas, and yeah, I hope everything is going to be helpful for you. Thank you very much.